Okay, so welcome to the next video in the systems programming series, and finally we're done reading chapter 1. So the next thing seems to be to come over to assignment 0. A lot of this is like, course logistics for what, the course that this was offered through, so we don't need to do that. The first thing that seems to be sort of doable is running the available HelloC program. I've already implemented some of this, but let's just kind of walk through this. So this is the code that was distributed, and all we have to do, right? There was also this makefile. This dive into systems PDF is not a part of it, nor is the fortune.c, but the HelloC and the makefile, they came with it. Now, this is code that I added, and I'm only commenting it out for now. So anyway, if you get your hands on the code, you can see what was originally distributed as part of the code. But it's basically just this without the commented code here. So that's what came when you sort of like clone the repository, basically. And all we're supposed to do is, set it up, make sure that our C compiler is all set up. So mine is, I think it was set up before I started this. And so because there is a makefile, right, we talked about this several videos ago, the whole point of a makefile is to run the compiler commands for you. So if I simply call make, it will basically grab the first and only, source code file to make into a binary, and so it will make the hello binary. So if I just come over here and I set and this is my terminal, and it's pointed to the directory where all of this is saved, right? So I have the things in the overall course directory, and in particular in assignment 00, and inside of assignment that's where my directory is pointing at assignment 00. And so all I have to do is call make, and it ran the compilation commands. And if you can see now that I have called make, suddenly there is this binary file here. And if you try to view it, VS Code warns you against viewing it. I don't really want to view it. But that, right, the compilation made that file appear. That is the binary file. If you viewed it, it would just look like gibberish, so there's no point in viewing it. And now we want to run it. So I can call /hello, and it runs exactly what hello.c says to run. What does it say to run? Let's just make sure that we understand that. Well, it imports the standard I/O. It defines the main function, as we know we must do when designing a C program. And we know that it always, by default, runs the main function of the file. So this is the function that gets run and must somehow be responsible for the printout that we see down below. What does it do? It prints exactly that, hello world, with a line break character. That's why, after hello world, it line breaks and then shows me the terminal prompt again. And in order to not throw an error, right, you have to say return 0, right? If you don't return 0, then when you compile, you're going to get a compile time error. And if you return any number other than 1, you'll get a runtime error, which means that it'll compile just fine, but then when you go to run it, you'll see the error at that moment. So anyway, so there it is, right? The first part of the assignment was simply to run this, right? Like, clone the repository and run this program, and that's exactly what we did. So good, we have finished the first part of the assignment. In the next part of the assignment, we are to implement a new program. We are told to specifically name it fortune.c, and it is effectively just a modification of hello.c. And we get to do whatever we want, right? Like the whole point is just to demonstrate that we know how to make a new file and run this new file. We should make sure that we edit the make file so that we can make this new file, right? So this time we're going to call make fortune, right? So previously I could just call make because basically there was just only one thing to to make. There's only the hello file. But now I'm going to add the Fortune file. So I uncommented it. This is editing my make file so that it will now actually have the power to make this Fortune program. I had to create fortune.c, but that's very easy, right? You just make a text file, call it fortune.c. That's all there is to that. And you can see here, right, commented out is how I actually made it, but I'm not going, right, like I'm going to just build it from scratch. So what's the first thing to do? We know that we're going to want to print something, right, presumably. I guess the instruction didn't say that we have to, but let's print something. So include standard io.h. So now we have the capacity to print things. We also, or now we want to define our main function. So int main, always. And and now we decide to do something. It doesn't matter what. We can printf, you name it. Let's just say test print or something very uninspired, and return 0 and done. So there's my Fortune file. Let's make sure that we remember to save everything that we did. And now I should be able, let's just see what happens if I call make. And it tried to update hello. Hello was the first thing, so presumably a make file. When you don't tell it what to make, it simply makes the first thing available. Makes sense, I think. But now let's specify make Fortune. Now it is actually called the commands. Notice, right, like what are these commands, right? So, okay, Fortune is the name of the command, right? So the Fortune that I typed right here after make, that's referring to this Fortune right here. So when I say Fortune.make, it knows to come over and look at this to know what to do. After the name of the command, colon with spaces, and declare the, basically the dependencies, right? The files on which this is going to act, which in this case is just fortune.c. And then specify the exact command line right? The terminal command that you would like to have run when you call make Fortune, right? And so the command that I want to run is almost exactly like the command for the hello program, except this time for Fortune. So very straightforward. It has made Fortune. You can see here it called the compilation command exactly that I wanted. You can see that the result is this executable binary. And so now we are able to execute that binary and hopefully see, yes, exactly, right? It does exactly what I told it to do, which is not pretty, but it printed test print with no line break because I did not specify a line break. I could have done that here, but somewhat it's actually kind of nice to show you what the call to line break does by omitting it and seeing what happens when you omit it. Anyway, there we go. I don't think there's anything more to A00. That it was a very, of course, just a barely a warm-up problem. There's all this stuff about submitting your work. Obviously, we don't do that. By the way, if you follow along with all of this, you're probably going to want to have all of these things installed. So you're going to, like for instance, if I were going to do this, I would pull up my terminal. I could do this in VS Code. I could do this here in a separate dedicated terminal. It doesn't matter which one. But so I would call sudo apt-get install cmake. And for you, something more interesting might happen. But for me, because my Linux, I updated this very recently, so CMake is already installed, so you're not really seeing anything interesting on your end. Probably it would ask you, do you, are you sure you want to install this? Type yes or no and hit enter. So you should type yes and hit enter, right? And then it'll install and so on. So anyway, so you would do this with CMake, and then you do it with Git and G++. You actually don't need Git. That was for the class, but you're not going to be submitting anything anyway. So, most of these things, though, you're probably going to be glad that you have. They may become important later in the class. So why not go ahead, install all of it. They're all small programs, so it doesn't like eat up space on your computer anyway. So, okay, and I think that's it. That's A00.